Here I have two objects suspended from a horizontal boom. The boom is 1.4 meters long. One object is suspended from the left side. It has a mass of 2.5 kilograms. The other object is suspended from 1 meter, measured from the left side, and its mass is unknown. This is the question. What is the mass of the unknown? We have some more information here. Since the boom is 1.4 meters long, we know its center of mass is located at the 0.7 meter mark, halfway between. The mass of the boom is 1.25 kilograms. And the boom is pivoting at 0.5 meters measured from the left side. So that's all the given information. We're going to use the first condition of the equilibrium, that the sum of the torques is going to be equal to 0. So the first thing I want to do is I want to sketch a free body diagram along with distances where those forces lie. Since I know that this is my pivot point, all measurements are going to be with respect to the pivot point. So F1, that would be the 2.5 kilogram, the weight of the 2.5 kilogram, would be exerted at 0.5 meters away from the pivot point. This would cause a counterclockwise rotation, and counterclockwise would be positive. Now the next force that we encounter would be the force of the pivot, but that's upward, and it also acts at the pivot, so there's no torque there, so we can ignore that force. That's not important when we do sum of the torques. The next force is the force due to the center of mass of the object, and that is going to cause a clockwise rotation, which is going to be negative. Okay, now where is that located? So since that's 0.7 from the edge, so from here to here is 0.7, and from here to here is 0.5, that means that this distance here, we'll call that dcm, that's equal to 0.2 meters. Okay, so now the next force would be the unknown weight. So that would be from here to here. Okay, what's that distance going to be? Well, since I know that from the left edge to the hanging mass is 1 meter, and the pivot point is located, this is half a meter, that would make this 0.5 meters. Now I know my diagram's not to scale, but all the numbers are here. So that's our free body diagram along with the relative distances which I need to calculate torque. So I just want to double check these numbers. 0.5, 0.2 in that direction, and then we would have 1 meter. 1 meter minus 0.5 would be 0.5. Very good. So now I have the sum of the torques is equal to 0. And we'll begin with the torque on the left. That's going to be a positive torque. So that'll be F1 times D1. Okay, and that's positive. Now the next force is going to be this at that distance. So that'll be a negative torque. So that'll be FCM times distance cm. And the next one would be F2 minus F2 times D2. And those three forces, this one, and this one, will provide torques. And the sum of those torques are going to be equal to 0. Okay, so let's start plugging in some of these numbers. So F1 is going to be 2.5 times 9.8, right? That would be F1, the weight, times D1, which is 0.5, minus FCM, which would be 1.25, times 9.8, times 0.2, and that's a negative torque, minus F2. Now I don't know what F2 is, but I know it's M times 9.8. That would be F2 times 0.5 That's equal to 0. So now I can use a calculator and calculate these torques. So we have 2.5. Oh, look at this. I can do this, right? I can get rid of the 9.8. Don't need to do that. So 2.5 times 0.5 times 0.5 is equal to 1.25 minus 1.25 times 0.2 is 0.25 minus 0.5 m is equal to 0. So then this is going to be 1.00 minus 0.5 m is equal to 0. So 0.5 m is equal to 1. So m is going to be equal to 1 divided by 0.5, which is 2.0 kilograms. Okay, so that's one way of calculating the mass suspended from a boom.